Anthropic just dropped Claude Managed Agents. If you wanted to make your own agents, not just using Claude Code agentically in the terminal, but have your own agents doing things autonomously, previously you had to have your own infrastructure, your own state management, like how does this agent have its own memory, permissioning, and reworking the loops the way that the agent works after every model upgrade. Now, Anthropic's got a feature allowing you to define your agents, tasks, tools, and guardrails, and they run it on Anthropic's infrastructure. So if you come in here to platform.claude.com, you'll see in this workspace a bunch of templates for different kinds of agents, which are now available for you, able to build, connect to your systems, and they can be long running and operate autonomously for hours. I'll walk through a detailed engineering blog article that Anthropic put together, and then I'm going to try putting together some managed agents myself and see how this feature actually works for me. So here in this section of the release article, they're talking about some of the things that teams are already building. So Notion now lets teams delegate work to Claude directly inside the Notion workspace. So if you've seen my full Claude Code course, I set up a Notion MCP to be able to do things with Notion directly from Claude Code. But I guess here that Notion is able to ship code and have knowledge workers use it to produce websites and presentations and have that be done autonomously in a long-running way, not depending on the computer being on. I found this one interesting. So this is the Vibe Code app, which is a service to make it easy for you to develop a mobile app quickly. So what this says is that users can now spin up the same infrastructure to build their apps 10 times quicker than before. And finally, this is something I want to try out today, this integration with Sentry. So Sentry is a platform to be able to log all your errors and then act on the errors. So what would be ideal, amazing, would be able to have an agent which sees an error and can automatically act on that error popping up in the application and then respond to it. I don't know how quick I'll be able to get to that, or if I'll be able to do that in just a quick tutorial here today, but I want to kind of push forward and see what the possibilities are. So we'll play around with that. So there's this new documentation here for managed agents, and you can use managed agents in this sort of GUI interface, or you can build them through Claude Code. So there's an interface for that. I think I'll be able to experiment with both. But one thing to keep in mind is that these managed agents are going to depend on your API key. So you're going to have to pay for API usage here beyond just a Claude Code subscription. And so you want to sort of think about this from an ROI perspective. Here on Anthropic's engineering blog, they talked a little bit about the ideas that went into making their managed agents, and I want to talk through a few of them, which I think are pretty important to know. So first, here is the main thesis. Harnesses, meaning things like Claude Code and Codex, encode assumptions that go stale as models improve. Managed agents is built around interfaces that stay stable as harnesses change. This really relates to me to some ideas I've learned from Nicolas Bustamante, who you should definitely follow on Twitter. And he had this article a few months ago called LLMs Eat Scaffolding for Breakfast. The idea is that every single time a new model comes around, all the stuff that we just built around the model to support the model's deficiencies are no longer relevant. And so he says here, it's Monday morning, 6:30 a.m. I already know what's going to happen this week. We're going to delete our code because models are eating our code. And so in the past, there were all these things that LLMs couldn't do, like reading PDFs, doing math, and handling structured output. Now they can, so we find ourselves having to rebuild the harnesses we make around them again. And part of the promise, apparently, with managed agents is to deal with this problem. And so here's kind of an example of this, is that in prior work, they found that Claude Sonnet 4.5 would end tasks prematurely as it sensed its content limit was approaching. And so they called this context anxiety, and then they added something called context resets to the harness, which is like the Claude Agent SDK or the Claude Code harness. But then when they use the same harness on Open 4.5, they found that behavior is gone. The resets had become dead weight. And so what they say is that they have created managed agents so that you'll be able to have these long horizon, like long running agents working on our behalf, but not dependent on any particular model. Next, the Anthropic engineers here explain the engineering problem that they encountered when they were building managed agents and how they solved it. So what they say here is that they started by placing all agent components into a single container, which you can think of as the isolated environment in which all these agentic things are occurring. And what they say is that they put the session, the agent harness, and the sandbox all in the same environment. And that made some things simpler. But what they ran into was a classical problem in infrastructure, which is this pet versus cattle analogy. So a pet is a named hand-tended individual that you can't afford to lose, while the cattle are interchangeable. And what happened, because everything was in the same place, is that when they were debugging and trying to iterate on building this thing, anytime something went wrong, an engineer had to go inside these containers. But because that container also held the user data, that took away their ability to debug what's going on. And so this gets quite technical, but basically what occurred is that they developed the right way to decouple this brain from the hands. And that's what makes this new managed agents idea finally possible. And so I thought the conclusion here is pretty interesting. With managed agents, they aim to design a system that accommodates future harnesses, sandboxes, or other components around Claude. So something you may think about when wanting to build one of these agents is that it would be really annoying if you have to build this thing from scratch every single time a new version of Claude Code or a new model comes out. And what the engineering problem here is that they're trying to solve is think about how to be robust and improve these agents over time without having to rewrite everything from scratch every single time a new model or harness comes out. So now I'm going to see what I can actually do with this interface. And this is totally new to me too. So I'm very curious, want to find out what we're going to be able to do. But some of these technologies in here are ones that I use right now. Like we use Slack and Notion at Payslice, where I'm the director of AI and ML. So maybe let's try making a support agent and see how we do. Okay, interesting. So it says answer customer questions from your docs and knowledge base and escalate when needed. So there's this YAML definition of the agent. This is the system prompt, which I guess describes how the agent works. These are the MCP servers that the agent has access to. And then there's a tool set, which I guess is just all the tools in the MCP servers that the agent has access to. So if I wanted, I could limit the sets of tools it has available. So let's try it out. I'm just going to say, use this template. Now it says your agent is created. Here's the call that made it. Next, configure environment. Ooh, well, that's an issue. Let me add some more credits. All right, I got some credits. So let's try this thing again. Go here. Use this template. Let's try this, configure environment. Okay, interesting. Let's say limited. I see. So if you choose limited, it's only going to have access to these MCP servers. If you did unlimited, it could access other things. And so unlimited might be good if we wanted it to be able to crawl the internet as well. Let's see how. Can I actually build this whole thing from here? That would be pretty cool. Support escalations. Let's try this. Customer support. Okay, interesting. So one of the annoying things with agents is you got to figure out how to store your secrets, where to store them. One of the issues that people have seen with OpenClaw, for example, is sometimes you'll have an OpenClaw group chat and other people will be able to exfiltrate your API keys easily. And so Claude Managed Agents, I guess, is in part promising to automate that away. Okay, so it pointed me at these docs, but it hasn't helped me get the right credentials. Okay, so how do I get those? It says connect via Claude.ai first. All right, let's try that. Settings, integrations, and then connect Notion and Slack. Okay, there's Slack. Allow. All right, so Slack is configured. Let me add Notion. All right, let's try this. Continue. And I'm also going to try Gmail because we have a support inbox for Gmail, so that might be a nice extension. Okay, that's pretty cool. So I did the Gmail, Notion, and Slack extension here. I don't know what this interactive thing means. I guess we'll find out. So let's come back here. I just connected via Claude.ai. Do I still need to give you tokens? Where? Let's just see what happens. Connect here. All right. So maybe that whole thing in settings wasn't needed. Can we add Gmail as well? Okay, that's pretty cool. So like, it's just letting me do it all here. Can we add Gmail? Yeah. I'd like to connect our support email inbox. So now or is there a Google integration? Okay, let's just skip email for now. Let's do a test run. Send hashtag Gabriel a message in Slack, or send a message in Slack in all paste slice summarizing the Notion workspace structure. This actually works. That'll be pretty fucking cool. Oh, this is, I guess, the test panel. Send your message in the test panel on the right. Okay. Wow. That's pretty fucking cool. So it's found like the Notion structure. Okay, we'll be able to make some pretty good use of this. Now, what I would love is if we can get this connected to our Gmail. That would make customer support so much easier because we have all these support emails that keep coming into this inbox. Cool. So this is the current session we have running. We've got this credentials vault. Let me go look inside here. I wonder if I can add a credential here. Yeah, so if you look here, none of these have like a Gmail integration. Okay, so we see here that a message came through. I look over here and there's an organization and then these standalone pages. So there were some errors that came through here. The whole thing seems to have taken about 2 minutes and 20 seconds. And I wonder if we're able to see how much it cost. Okay, that was actually pretty freaking expensive. So if you look here, this thing cost, I think, $1.97 to use this tool for 2 minutes by API. So if you're thinking about what use you want to make of this, I actually, after going through this, I don't know if I would recommend this to most people, because what probably makes more sense if it's going to be this expensive is to have something like OpenClaw backed by Codex. So this was a nice experiment, but looking at this, I actually wouldn't want to pay $2 for some simple message like this. And so that is the downside of locking yourself into a very Claude heavy ecosystem, that you're going to have to pay quite a bit of money for these agents. And so the alternative, which is what we currently use right now as our internal Slack bot, is to use some open source framework like this one. This is Pi, which is the framework which OpenClaw is built on top of. And then you can either use Pi with your Codex subscription, which is OpenAI's coding agent. And with the subscriptions, you're getting a big discount on API usage. As you saw, that simple Sonnet 4.6 query cost us about $2. Or you can use OpenRouter under the hood, which has a bunch of different models available, a lot of which are cheaper than Opus or Sonnet. So like this one, you can see Opus here costs $30 per input, 1 million input tokens, and $150 per output token, whereas GLM 5.1 costs, like 5% of that, or like some small fraction. This is in fast mode, so it's more expensive, but it's still pretty pricey. There are other models you can try out for agentic applications. But if you have some situation where, for example, you are doing sales, you're working on enterprise deals, and time to lead is extremely important, then something like this could be useful to get agents spun up really quickly so that as soon as an incoming lead comes in, you're able to respond to it. And then because of the ROI on responding to a lead quickly, maybe $2 for an agentic session is actually worth it. Anyway, hope you found that intro to this new feature useful. If you are learning Claude Code, I recommend my course, which I just put out a few days ago. It's a complete 3-hour course on Claude Code where I walk you all the way from not knowing anything about Claude Code until being able to make and deploy your own web apps, available for free here on YouTube. If you've got any questions about Claude Code as you go through it, or just generally, you can join my school server, the AI MBA. We've got 1,600 people now, all pushing to get to the cutting edge of agentic coding. If you want some personalized mentorship from me to get to the cutting edge of agentic coding, then I have a paid school server, the AI MBA Pro, where we have weekly calls and all sorts of extra goodies for the people in the group. So hope to see you in one of those places soon. Otherwise, peace and see you guys next time.